east, right? Nobody will give a single penny to you to work on that particular problem statement. So it does not make any sense. So that means what? The hypothesis, when we develop, it should be very much aligned with the objective of the study, which the researcher, or sorry, the funding agency is ready to pay for. So one has to be very, very careful on that also, right? One. Point number two is hypothesis has two parts. One is
null hypothesis and alternative hypothesis.
one. Though there are two parts, one is null hypothesis, another is alternate hypothesis. These are complementary to each other. That means this is the transpose or the mirror image of each other, right? Or and has to be mirror image now is not the right term, but it is complementary is the better term, where one is transpose of the other. So the point is that null and alternate hypotheses are mutually exclusive and collectively exhaustive. That means it should not leave. When I'm talking about null and alternate hypothesis, it should talk about all the possible situations, but there should not be any overlap between null and alternate hypothesis. One. Point number two was when we talk about null hypothesis is a statement which everyone agrees to, right? Everyone agrees to. What's the meaning of this? That means that nobody is questioning that. Everyone is saying that yes, we agree to this particular point. Okay, like for example, everyone says that more a person spends time in an organization, more would be the loyalty to organization. Or you can say more a person spends in, time in organization, more would be productivity. There's something that everyone is agreeing. That's why people are getting promotions. Then a lot of incentives and all. But as a researcher, I'm questioning that. Assume that, right? I'm questioning. I'm saying that no. The more the person spend times in an organization, the more complacent the person is, the poor would the productivity. There's something that I want to prove. So that means what I'm challenging the common belief that everyone has, right? As a researcher, I'm challenging that. So that would be our alternate hypothesis. Something that researcher wants to prove against the common belief. Okay. So that is what is my job is to. So in this way, yesterday we talked about a few more examples and had clarity on in terms of null and alternate hypothesis. Okay. By any chance, and we also talked about that by any chance, if we swap null and alternate hypothesis, right, what would be the repercussions? Hmm? Yeah, Amika, were you there yesterday? Yeah, if just you would like to say something on this point, if at all by any chance we swap our hypothesis, null and alternate hypothesis, what physical interpretation, or you can say physical interpretation, I'm interested in terms of the implications. What implications it would have on our study? Yeah, Santosh Kumarji, um, do you remember something on this, please? No, I cannot hear you. Looks like no, still your voice is not coming. No problem. Please work on that, please. Yeah, Mr. Sharma, can you help me? If by any chance we swap, if we swap the null and alternate hypothesis, what implication it would have on any research?
In that case, we will be trying to prove something which is already accepted by people,
Mm-hmm.
and we are trying to disprove something.
Mm-hmm. So what?
So our interpretation will be wrong.
Okay. No, wrong means what? So what? See, you are trying to prove something that everyone agrees to. So what? What you're saying is right, but a little more Revelation is required.
So in terms of funding, I will not get funding.
Oh, yes, absolutely. This is what I wanted to hear, right? That if something that has already been proved, right?
Yes.
Or everyone agrees to, and you are also saying that give me money and I'll prove that. You say, when everyone knows that, what's the point of giving you money? So keep your mouth shut and keep. There's no point of investing anything, isn't it? So that is the reason why what you are saying is right. Is there's that swapping of hypothesis does not make any sense to the study, right? And that is the reason why one has to be very, very careful in writing hypothesis, because by any chance, if we swap it, the whole purpose of the study get defeated, isn't it? Right. So this is the next point is that when we talk about hypothesis, it is the responsibility given by the funding agency to the researcher to prove that null hypothesis is a wrong statement. Right? So there's a reason why all these are going, isn't it? So that is the reason why there's something called testing is required, right? Testing of hypothesis. So with this, this is something that we discussed yesterday, right? And now the next point that we have to talk about is that the testing. But before that, if at all you could think in any manner that you are struggling with, or you want a little more detail on anything that we discussed yesterday, including hypothesis development and all, please feel free to talk about that. Yeah. Any confusion, anything that you wanted to discuss once more? Okay, fair enough. So that means there's a green signal. We can go ahead in terms of testing, right? Uh, Let me just share the screen. So you can see this when we talk about testing, right? Hypothesis testing is the thing, you know, as I told you yesterday also, that very first thing that we have to start with is the objective, deciding the objective, not the research questions. Then based on that, you did a little bit of homework and then try to get your funding. Once you got your funding, you have told very clearly this is the objective that you want to do. Those objectives are translated in terms of hypothesis. Hypothesis has two parts, null and alternate hypothesis. So writing alternate hypothesis is sufficient, no need of repeat saying null hypothesis also, although there's nothing wrong in writing both also, but usually in journal paper they prefer to write only the alternate hypothesis. Once the alternate hypothesis written, is very clear that what researcher wants to prove, okay, and what researcher wants to reject. Now the next thing comes in is to devise your questionnaire. So questionnaire completely, you know, translates the hypothesis questions directly, right? And through that we ask questions. Now the next step is to identify, you know, what is to identify that who should be your sample, isn't it? So you identify your sample, who should be your respondents. Okay. So when we talk about respondents, so there is the different techniques of sampling, right? One is called random sampling, right? Second is another part is non-random sampling. Random sampling has again a few more points. That is what is stratified sampling, cluster sampling, sequential sampling, right? So these all are different types of sampling methods. Okay. Non-random method is more of a convenience point where I'm going to nearby people and going to the mall and getting the information. So it is a convenience sample. Okay, snowball sampling. So these all are the sampling methods. Now you tell me one thing, that why there are so many different types of sampling methods. What may be the reason for this sampling methods? Hmm? What are different sampling methods? No, I'm not asking what are different sampling methods, but the point that I'm asking is, why do we need these different types of sampling methods, right? So please understand. See, the thing is, when I'm talking about this, we are already done with this part, right? That our null and alternate hypothesis are clear, isn't it? Now the next
Sir, our
part is,
data,
yeah, go ahead, please.
sir, our data might be, sir, the sample might be, sample of the population might be distributed in a different manner. So based on whether it is a homogeneous distribution or an heterogeneous distribution, we can take different type of sampling so that there is no biasness of collecting the data.
Absolutely, absolutely. Wonderful, Sangeeta ji. Thank you very much. The point is very clear that if at all this is my population, I am taking a sample. We want that sample to be the true representative. Right? Yesterday we talked about this. We want our sample to be true representative of the population, isn't it? Then only whatever decision we'll take based on our sample, we will able to make it. If you remember, yesterday we talked about an example of cake. Okay. So here the assumption is I should take sample in such a way so that this piece which I'm testing should be the representative of the whole cake, isn't it? So the one has to be very careful in this case, and that's why we want to have we have so many sampling methods to ensure that the sample that we are getting is close to accurate. And there's the reason why we talked about this. Wonderful. Okay, so that's really good. Thank you. Now, when we talked about the sample, assume that we have already decided that how we're going to take our sample. Now, what is this identification of the population? What is the meaning of this? Why do we need to identify the population?
For accurate data collection, sir?
Yeah. That's right. For accurate data collection, instead of that would be, what you're saying is absolutely right. But a better word would be based on the objective. See, the thing is, our objective is, suppose we are in manufacturing some drug, right? So some medical drug we are manufacturing. So we have changed a bit in terms of one of the constituent. Right now we have to test it on, suppose this is related to diabetes based tablet, and this R&D that we are working on is more for the young guys, right? Those who are between 25 to 35 and have some diabetic symptoms. Okay, so that means this particular addition is only for their tablets. So that means what we decided, the scope of our work is only between 25 to 35 years of patients. So this is what my population would be. Okay. Now from that population, I am taking a sample, right? So this if you see, this is the population. So all these green guys are my sample. Okay. Sample. Now the question one may ask is, how to decide? We already decided that how to take that sample. But the next question would be how to decide the number of sample. Number in a sample, or we can say sample size. How to decide sample size and what implication it would have on study? How to decide sample size? Any suggestions on this? How to decide sample size?
So would it be correct if I say, out of the total, say, a population that we have identified, 50% we would take as a sample,
No.
so that
50% would be
the
too high. 50% would be too high.
By finding out the size of population
Yeah.
and then determining the margin of error.
Yes.
in order to
margin of
avoid
error.
any error, sir.
Yeah, absolutely. So that is what is absolutely right, that the margin of error will play a role here. Okay, wonderful. That's great. But some population size has no role to play, irrespective whether we are going for pan India or we are only going for Northeast India, right? Eastern part of India. So the population size has no role to play in sample, right? So there's a way how we find sample size, and the sample size is calculated based on the margin of error. Second thing is confidence level that we want to work on. And the third thing is the standard deviation in that sample, in the population. So based on this, we find our sample size. Now the question is, why all we are worrying about sample size? Why? Why we are worrying about sample size? Any reason for that? The bigger the better, isn't it? The bigger the sample size is, better would be the conclusions. Smaller the sample size.
Because sir, we have to save time and money.
Absolutely. So there is a reason why we are going for sample. Otherwise, one can go for 100% inspection, isn't it?
Yes.
Wonderful. So we have to save time and money. That's why something that is optimum or the minimum sample size. That's why we always say that we have to find the minimum sample size. So there are a number of methods to find this. The formula that we use here is usually we say it is sigma into z upon e square, right? Ignore these terms. If it's sigma is standard deviation, z value. Any idea about this z value? What is this z value? Because you know why I'm saying this. And some of our friends must have used the z value earlier also, right? The p value. Yeah. Sometimes we test our hypothesis and based on the p value, isn't it? What is this p value? Anyone but the question is only for those who have tested hypothesis, and I'm sure you must have, right? Because most of our friends are PhD here and some are pursuing. Most of our friends are masters, right? There also we write dissertation. So anyone who has used null and alternate hypothesis and tested it using some p-value, because you know, until unless this p-value, z-value is not clear, I really doubt that we'll able to go ahead.
Is it the significance level?
Yeah, it's a significance level. Yes, significance level is related to that. Significance level is alpha, right? Which is 1 minus confidence level. So my significance level is supposed 5%. What it has to do with our p-value? There's, yeah, I'm just waiting.
Probability. P value means probability.
Probability of what?
Confidence, maybe.
The probability of error.
Yeah,
5% chance of error.
yeah, is a error, but what type of error we are talking about? See, the thing is, basics should be very clear, because we all have to teach students also, right? So when our fundamentals are clear, then only we can teach our students these things in clarity, so that they will not make any mistake. So when we are saying, you know, I can sense that you have tested hypothesis, and when we are using any software, it gives me p-value, isn't it? And using that p-value, I decide whether to reject or not to reject null hypothesis.
Yes.
But from where the p-value is coming, right? If I ask you to solve it manually, how would you find p-value? This is what I'm asking you. Or if the thing is we have to solve a problem manually, how would we do that? Yeah, those who are not keeping videos also can answer here, please. And yeah, because I can see not many of our friends are participating here. So I'm really not getting whether that you guys are getting what we are talking about here or not, right? Because it does not make any sense if you're spending a time also, and it is just a small tick in your getting certificate. So if you're spending some time in, let us have quick discussion and ask questions as many as you can. Because when I'm asking questions, only few of our friends are responding here. I really appreciate that. Others are not. When HRDC Neo is organizing workshop or training program, there's a purpose for doing that. It's not just to add number that I have attended these many trainings and all. So the purpose is to learn, I believe, right? So we cannot learn unless we not participate. So I'm repeating my question here, right? There's no point of talking about hypothesis testing if we are not clear on this p-value or z-value. If we are not clear, at least you tell me. I'll take you through the z-value. But without that, not able to understand. Please understand that.
Please
So that
explain,
is,
sir.
huh?
Please explain, sir.
Sir, can we obtain the p-value? So we obtain the p-value from the z-test if we are doing manually.
Mm-hmm.
And say, sir, the p-value gives us a picture of the probability. It is the probability value at a
Yeah.
particular degree of freedom and the confidence interval. So it tells us whether our data is normally distributed or not. So whether it falls within that.
No, it has nothing to do with finding the data is normal or not, because there is another test, Shapiroff-Wilk test and then Darling test, that are for finding data is normal or not. Now, as far as p-value is concerned, it has nothing to do with confidence level. Confidence level is different thing. Significance value that Mr. Kanchan was talking about has to do with confidence level. You're absolutely right. But p-value is different thing altogether. So let me just take you to the z-value first, because let's try to understand it. Okay. Let me just search my. Okay, so you can see here that yesterday we talked about normal curve, isn't it? So when we talked about normal curve, we talked about the 68%, then 95%, 97%, isn't it? With an example, we try to understand that. And then once that is clear, the next part is that but when we have you remember that yesterday I drew a curve, and for that 50, 51, 52, 53, 49, 48, 47, These are the numbers that I drew. I wrote when I was drawing this normal curve. So here we are writing the numbers, right? Or the shaft diameter or the weight. But sometimes what happens is when there are more than one or different normal, or you can say the units that you're working on, or different numbers that you're working on. That means what? One bag is of 50 kg. So for that, this normal curve is there. There will be one bag of 25 kg. So another normal curve will be required. 25, 24, 23, 24, 23, 26, 27. So for different units, varieties, right? A different curve is required. It is sometimes cumbersome to understand. So for that, we convert that into something called a standard normal distribution. Okay. So standard normal distribution says that, converting this curve, so this shows the curve for the bag with 50 kg. Okay. So this is 51, 52, 53, 49, 48, 47. There's another bag that we manufacture, right? And it is 25, 24, no, 26, 27, 24, 23, 22. Like, so if you see for this, a bag which this weight of the bag is 50 kg mean, we have to draw this curve. For a bag with the weight of 25 kg, we have to draw this curve. So for that means for different units, right, we have to draw different curves, isn't it? So in order to get away from that cumbersome thing, so what we can do is we can draw something called, so these are normal curves. This one and this one. What we can draw here is there's something called standard normal. So if you see the x-axis of this curve has the unit, right? Unit means 50 kg. Kg is the unit here. 50 kg. This is a 25 kg and all. So what I want to do is I want to convert this into a standard normal curve, which should have something called dimensionless number, which is represented by our normal, or you can say coefficient of normalization. That's called normalization, normal coefficient, right? So this is that we are converting our x-axis on. So his x-axis is, this formula is x minus mu divided by sigma. If you see here, our mu was 50 and standard deviation was 1. Now let us convert this curve A into standard normal curve. Okay. So here x is 50. So it is 50 minus mu is 50 divided by 1. So it would be 0, isn't it? So that's why I'm writing 0. So what I'm doing here is I'm converting this curve number A into standard normal curve. For that we use this as our formula. Okay. Now the second point is this one, 49. Okay. So it would be 49 minus mu. Mu is 50 divided by 1. So it is minus 1. So here in place of 49, I am going to write minus 1. Now let us go for 51. So this would be 51 minus 50 divided by 1. So it is 1. 52. 52 minus 50 divided by 1. So it is 2. So likewise, it will be 2. Likewise, it will be 3. Okay. Likewise, this side it will be minus 2. Likewise, this will be minus 3, right? So what we have done is we have converted our normal curve, which has numbers there, to something called standard normal curve, which has z value as the x-axis, right? Now let me convert the curve B onto standard normal curve, right? So for this, let me just rub these points because our data is changed now. So I can see here that for 25, it would be 25 minus 25 upon 1. 25 is the x value. 25, this 25 is the mu, and 1. So it will be got 0 here. Again, it will be 0. If I see this part, 26, so it would be 26 minus 25 upon 1. Because here also, our mean is 1 and standard deviation is, mean is 25, standard deviation is 1. So this would be 1. Here 1. 27 minus 25 divided by 2. Sorry, divided by 1, we got 2. So we got value 2. Here is 3. Minus 1, minus 2, minus 3. That means what? Irrespective of whatever may be the x-axis here in the normal curve, finally the standard normal curve gives us this value, right? Minus 3 to minus 1. Now, if we relate our normal curve definition, we can say what? That if my z value is between minus 1 to 1, it covers how much percent of area?
95,
68.
68,
This is
68.
only one sigma, one this side and one this side, right? And then we say that if at all it is covering minus 2 to 2 this side, so this would be
95.
95%. So that means what? Now we do not have to see these dimensions there, whether it's a 50 kg or 25 kg or 10 kg. We just have to see these numbers, and based on that, we can say that whether it is within limit or not. All of you agree with me on this?
Yes, sir.
Yes, sir.
Wonderful.
Yes, sir.
So this
Yes,
is where we have to use this z table based on this. If at all, suppose my interest is, I'm taking another, suppose another value. My interest is between this value and this value, right? If my interest is in this, it will be difficult for me to find manually. That's why we go and see our z table. Okay, to find the area under the curve. Area under the curve is the most important part that we are interested in, because it will help us in our hypothesis testing. But before jumping on to the hypothesis testing, let's have a small exercise so that we all, those who have not done this earlier, would walk with us. So now let me tell you that the table, or you just, may I request you to, if to open a Z table with you? Yeah, open your Z table and then we'll solve a problem statement here, right? Yeah. So if I can share, that is a table where it is. This is how the Z table looks like, okay? And for any value of the Z, what you can say is, if I ask you that, okay, this is my curve, okay, and my Z value is 1.75, right? This is my Z value, okay? Can you tell me this area? Can you tell me area under this curve? If my Z value is 1.7, so how to see that? I'll tell you, but wait, I should tell you first, then only I should ask it. Oops, what this happened? So the thing is, if I'm interested in my Z value is 1.75. If I ask you how we can find Z value, you all know that, right? Z value we can simply calculate from Z is equals to x minus mu divided by sigma. What is this x? X is the x value at this point, which was maybe 51 or 51.5, whatever. So we got our 1.75. So once we got our 1.75, you can see that this is my 1.7 and this. This is my 1.75 value. That means what? The area, this area, not visible because of this blue background. This area is what? 0.4599. That means it is covering 45.99% of area. Is it okay with you? You got my point? Yeah.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Anyone who is still struggling, please.
Yes, sir.
Wonderful.
Yes,
So
sir.
that means what? Now, if I give you any value, you should be able to find that for me. Okay. So let me ask you that suppose my mu is 5. Okay. My sigma is 0.1. And I'm interested in finding area under the curve where my x value is 6.5. Can you find this for me, please? 6 is okay. Even 6 would be very heavy. Wait. Let this to be 0.05 and this value should be 6.4. Please tell me area under the curve. The Z table is in front of you.
Sir, can you kindly repeat the values?
Yeah, I'm repeating once again. Assume that the data that we are working on, population mu, also mean is 5. Standard deviation is 0.5, right? And I'm interested in finding for a value 6.4, I'm interested in finding area under the curve. So the very first thing that we have to do is we have to draw the curve. So this is my curve, right? You have to find 0 is my Z value here. You have to find Z value for 6 against this value 6.4. Then this is the area under the curve that you have to find for me. And you have to tell me what is the area. Then I will tell you what exactly is the physical significance.
So it would be 0.4812. That means 0.48.
It is
8%.
0.482, 48%. Let us wait for
4812.
others also to respond, please.
4812.
Yeah. Yeah, let us just wait for a couple of more friends also.